Assalamualaikum. I am Joita Haldar, IT69, presenting the project of Group 5 named Automated Face Mask Detector and Mask Distributor. The other group members for this project are ID 84, 85, 88, and 89. The first objective of this project is designing an automated face mask recognition to differentiate among people who wear face mask and who don't. Since the declaration of COVID-19 virus as a pandemic by WHO, efforts have been made by various parties to reduce the spread of the virus. The world is more depending on the implemented intervention by the authorities. For instance, physical distancing and wearing a face mask in the public place to impede COVID-19 transmission. Furthermore, since the new normal has been implemented, the people are forced by law to wear a face mask in the public place and wherever they interact with other people. So, designing an automated face mask recognition to differentiate among people who wear face mask and who don't is our objective. Then, detecting people with mask and without mask. Then, allowing people enter if he or she has a mask. Or blocking path of the people if the person has no mask. Finally, provide a mask to the person if he or she is detected with no mask.
So now we'll talk about the methodology. This project consists of two parts, software and hardware. We used convolutional neural network to perform traditional classification tasks for our software part. This part of the project was developed using a machine learning technique through an image classification architecture named MobileNet V2. Google introduced the MobileNet V2 architecture, which is based on CNN. The associated procedure regarding software parts are collecting the data, pre-processing of the dataset, splitting the data, building and testing the model. In hardware portion, we uploaded the code to the hardware and implemented the control circuit. As we are using machine learning technique, we need a dataset to train our model. We used about 5,000 data with mask and 5,000 data without mask. We used cropped images, so the only visible image obtained is the person's face.
Assalamualaikum. My ID is 89. So now our first step of procedure part is data collection. We built our face mask recognition model with a dataset that has two types of class, such as with mask and without mask. We used 5,000 images of masked people and another 5,000 without masks. We applied image processing to find out people's faces from the images, then applied our transfer learning model. Next step is pre-processing. This is very significant for our future model building, as it helps to increase our neural net's accuracy. In this method, we applied 4 steps. First step is resizing the image size to run the model efficiently. Then we converted these images into array. After that, we used to pre-process the images for MobileNet V2. And last but not least, we performed one-hot encoding to transform our label variable into numerical variable, which is helpful for the processing of our data.
Assalamualaikum everyone. I am Vedant Talukdar. My ID is 85. Now, after the pre-processing phase, we have split the total data into 2 batches. These are training data and testing data. Training data comprises of 80% and testing data comprises of the rest 20% of the total data. In our each batch, there are both images of mask and without mask. For building the model, we have followed some steps. Firstly, we constructed the training image generator for augmentation. For augmentation, we took the following parameters into consideration. These are rotation range, zoom range, width shift range, height shift range, shear range, horizontal flip, etc. Then we compiled our model with MobileNet V2 and trained our model. And lastly, we saved our model for the future prediction process. Now, for the circuit implementation, we have used Arduino Uno as our microcontroller. We have connected our first servo motor with the microcontroller whose purpose is to control the movement of the people. Secondly, we have connected our another servomotor with the microcontroller whose purpose is to provide mask to the people who has no mask. This is how we have implemented our circuit in practical. Now we will watch a short video demonstration of our project.
So as I am sitting without any mask, the red square is showing no mask. Now I am sitting without mask as the square shows no mask. When I put on the mask, the square gets green and it is showing mask 100%. Here a person is sitting wearing her mask, and so the battery is upwards and so she can go inward. And now as the person takes off her mask, immediately the barricade goes downward, blocking her path, and she was given a mask. Now again, when she wears the mask, the barrier is upwards and so she can go inwards.
Hello everyone, I am Rajni Nimran Roya, ID 88. Now we see results of the software part of our project. It is detecting no mask as the person is not wearing any mask with 100% accuracy. And now it is detecting mask with 100% accuracy as the person is wearing the mask properly. When the person does not wear the mask properly, it is detecting no mask, but the accuracy is low. In this graph, we can see the training loss and accuracy of our project. Limitations. We are still working on providing masks for multiple persons. If the lighting is not adequate, our project faces problem to detect the face. The accuracy of detecting designable mask is low. The accuracy of detecting is low when the person does not wear the mask properly. The project needs to be trained with more dataset.